Welcome to my channel. In this session now we are going to discuss about finding the Laplace transform of sine hyperbolic 4t using the first principle. By the first principle, the first thing that we've talked about is that we need to understand the first principle formula. And by the first principle formula, we know that the Laplace transform of our function f of t is going to be equals to integration with respect to our limits, the upper class limit and the lower class limit, exponential negative st we multiply by our function f of t, and our integration is with respect to dt. At this point now, we've just denoted the first principle formula. Now let us start our working. We were told to find the Laplace transform of sine hyperbolic 4t, to mean that the Laplace transform of sine hyperbolic 4t is going to be equals to integration with respect to our limits 0 up to infinity, exponential negative st we multiply by our function f of t. The function f of t, we understand that is equals to sine hyperbolic 4t, and our integration is with respect to dt. We can change sine hyperbolic 4t into an exponential by using this formula, whereby we say that sine hyperbolic x is always equals to a half. We multiply by exponential x, we subtract from exponential a negative of x, to mean that sine hyperbolic 4t is going to be equals to a half into exponential 4t we subtract from exponential negative 4t. Since our x will now be equals to, we will equate it to 4t. After conversion of now sine hyperbolic 4t into an exponential, because sine 4t is equals to whatever we are having here, we can go back to our working, whereby we say that the Laplace transform of now our function f of t is going to be equals to integration with respect to our limits, exponential negative st sine 40. Sine 40 is going to be equals to a half into exponential, because this is now the function f of t, 40 we subtract from exponential negative 40, and our integration was with respect to dt. At this point now, we can come and factor out a half because it is not a term of dt, and simplify our exponentials by using the laws of indices. And this is what we are going to have now. The Laplace transform of our function f of t is going to be equals to integration with respect to a half, integration with respect to our limits. We take exponential, we multiply by this exponential, and we are going to have exponential negative st. Now here we are opening our brackets, exponential 4t. We subtract from, here we are going to have exponential negative st. We multiply by exponential a negative of 4t, and our integration is with respect to dt. Up to this point now, we can use the laws of indices to reduce the number of exponential. And by using the laws, by applying the laws of indices here to reduce the number of exponential, we understand that when the bases are equal and it is a multiplication, we take one of the bases and we add the powers, to mean that we are going to have the Laplace transform of our function f of t is going to be equals to a half. We take one of the bases, exponential, in bracket negative s, we factor out our term of t, we add to 4. Here we are going to have t. We come and subtract from exponential, and here we are going to have negative s. We subtract from 4, and we factor out our term of t, and our integration was with respect to dt. From this point now, we can do our integration to respective to each and every term. And by taking our integration, we understand that the Laplace transform of our function f of t is going to be equals to a half into, here now, exponential negative s we add to 4t. It is going to be all over negative we add to 4. Negative s we add to 4. And since our integration was with respect to our limits, you should not forget about the limits, whereby this one is going to be our upper class limit, the lower class limit. We subtract from. At this point now, we are going to have exponential into negative s, we subtract from 4t, all over negative s, we subtract from 4. And our integration was with respect to our class limits. Let us now do away with the class limits that we were having. And by doing away with the class limit, we understand that the Laplace transform of our function f of t is going to be equals to a half. We come and multiply by 1 all over negative s we add to 4 into exponential. We insert the upper class limit and the lower class limit. By inserting the upper class limit and the lower class limit, we are going to have negative s we add to 4. We come and multiply by the upper class limit, because we replace with the function f of t. We subtract from exponential negative s we add to 4. We come and insert the lower class limit. We subtract from, this is our first bracket, we subtract from the second bracket. We are going to have one all over negative s we subtract from 4. We multiply by exponential negative s we subtract from 4. The upper class limit, we come and insert. We subtract from exponential into negative s, we subtract from 4, we come and insert our lower class limit, and then we close the bracket. Whatever we've expanded here is our first bracket, we subtract from whatever we've expanded here by doing away with our class limits is whatever we are having there. Let us now do our working, whereby we say that it is the Laplace transform of our function f of t is going to be equals to a half into 1 all over negative s, we add to 4, into here exponential raised to a power of an infinity, we are going to have 0, we subtract from exponential raised to a power of 0, we are going to have 1. We come and subtract from here, we are going to have 1 all over negative s, we subtract from 4, into here we are going to have 0, we subtract from 1. At this point, we understand that this negative is going to affect whatever we are having on the denominator. Hence, we can come and say the Laplace transform of now our function f of t is going to be equals to a half into 1 all over s. We subtract from 4. Negative multiplied by this by a negative is going to be a positive. Negative multiplied by a positive is going to be a negative. We subtract from here, we are going to have 1 all over a positive and a positive. Let us now simplify whatever we are having within our bracket. And by simplification of whatever we are having within this bracket, we are going to do our cross multiplication, whereby our function, the Laplace transform of now, our function f of t is going to be equals to a half into, we take whatever we are having here, 1, whatever we are having here, we multiply by 1, and we are going to have s, we add to 4, we subtract from 1 into s, we subtract from 4 all over whatever we are having on the denominator, s multiplied by s, we are going to have s squared, s multiplied by 4, we are going to have plus 4s minus 4s minus 16. Let us open our terms on the numerator. Now the Laplace transform of our function f of t is going to be equals to a half into s, we add to 4, we subtract from s, we add to 4. Here we are going to have a positive, that here we are going to have a negative, and here we are going to have a positive. All over here on the denominator, this one is a positive, this one is a negative, they are going to cancel out, and we are going to have s squared, we subtract from 16. At this point now, we are going to have the Laplace transform of our function f of t is going to be equals to a half into, here we are going to have, this one is a positive, this one is a negative. We are going to have 8 all over s squared, we subtract from 16. And lastly, we can come and have the Laplace transform of our function f of t is equals to This one and this one will cancel, and we are going to have 4 all over s squared we subtract from 16. And this is now the Laplace transform of sine hyperbolic 40. To mean that when you've been told to use the first principle formula in finding the Laplace transform of sine 40, this is how you go about it. But you can, in some instance, you can be told directly to get the Laplace transform of, let's say, for example, the Laplace transform of sine hyperbolic 7t. We understand that 7, at this point, 7 is equals to the term of a. To mean that we are going to have now 7 all over s squared we subtract from, here we are going to have 49. You can be told find the Laplace transform of, let's say, sine hyperbolic t. Here we understand that the coefficient of t is equals to 1. To mean that we are going to have 1 all over s squared we subtract from 1 squared, which is equals to 1. And you need to understand now the difference between sine hyperbolic and sine. Sine hyperbolic are for hyperbolic function, the trigonometric hyperbolic function. But for sine, you can be told what is the difference between, for example, you are working out and you are having a problem in your answer. When you've been told to find now the Laplace transform of, let's say, sine 3t, you will find that sine 3t is equals to 3 all over s squared, but we add 2 to 9. To mean that for hyperbolic function, here we are going to end up with a negative. For trigonometric function of sine, here we are going to end up with a positive. And that is the distinctive characteristic between the two of them. Let us now meet in my next class, whereby we are going to discuss about the Laplace transform of cos, deriving the Laplace transform of cos hyperbolic at, and an example in it. Thank you for your time.